Propadiene is an important feedstock for organic synthesis, and an important source of propadiene is from cracking of hydrocarbons. Propadiene is often available as a mixture with other gases such as propyne. The separation of propyne from mixtures with propadiene is difficult because of small differences in boiling points, the order of 10.8 Kelvin, and small differences in molecular sizes. This problem of separation of mixtures of propyne and propadiene is addressed in this paper published in Nature Communications in 2021, in which 4 different metal organic frameworks have been investigated and tested for separating mixtures of propyne and propadiene. A more recent development in advanced materials that is just available online describes the synthesis of a anion pillared MOF, copper, zirconium, hexafluoride, TPA, where TPA stands for tripyridine 4-yllamine. This MOF has capacious cage-like pores and specific anionic propyne trapping sites, and this development results in benchmark propyne-propadiene separation. The MOF copper zirconium F6-TPA exhibits excellent water and thermal stability. In order to demonstrate the efficacy of the developed MOF copper zirconium hexafluoride TPA, breakthrough experimental data are presented in this paper at 3 different flow rates of 0.8 milliliters per minute, red circles, 1.4 milliliters per minute, green squares, 2 milliliters per minute, blue triangles. As should be expected, the experiments with the lowest volumetric flow rate at the inlet breaks through last, and the experiments with the highest volumetric flow rate at the inlet of 2 milliliters per minute breaks through earliest. The first thing to do in such type of experiments is to replot the data in terms of a modified time parameter as x-axis, where the modified time parameter is the actual time t in minutes, say, multiplied by the volumetric flow rate at the inlet in units of, say, milliliters per minute, divided by the mass of adsorbent. In this case, the mass of adsorbent is 0.57 grams for all 3 experiments. The units of this modified time parameter is milliliters per gram, which is equivalent to liters per kilogram. If we plot the data in this manner, we note that all 3 breakthrough experiments collapse to yield a unique breakthrough curve, and that is a confirmation that the breakthrough experiments are consistent. The continuous black solid line here are breakthrough simulations using unary isotherm data as inputs and ignoring diffusional limitations. There is a pretty good agreement of the experimental data with the breakthrough simulations. The breakthrough simulation methodology is described in my presentation, Transient Breakthrough Simulations, on my YouTube channel. So the important messages to take home from this advanced materials paper is that copper zirconium hexafluoride TPA is a viable MOF for selective adsorption of propyne to produce purified propadiene at a record productivity. The breakthrough experiments are consistent, and the experiments can be matched very well with transient breakthrough simulations in which intracrystalline diffusional influences are ignored.